Thank you, Chairman, and I'm very happy to see all of you again and some new faces. It is my pleasure to report some updates from the previous report. This morning I focused some new research results in the past 9 months at the Kibo in ISS. The contents of my presentation this morning, the first one is the Kibo utilization status of this year, 2010, and also that including the strategic utilization plan in near future. The second part of my presentation, including our collaboration activity with our Asian colleagues. Those are student public rights, promotion activities, and bilateral cooperations. Each of these contents are detailed, explained or presented by other presentations, so I do not present detail all of these, but general aspect, general introduction of these collaboration activities. Well, this chart shows you the current general schedule of Kibo and its utilization. We are now in the end of 2010. So the Kibo module itself almost completed. And in the future, Japan plans to launch the HTV transfer vehicle once per year. The next HTV, the number 2 HTV launch is scheduling now early in 2011. For Japan, it's the end of fiscal year of 2010. In HTV2, we plan to launch 2 new science facilities. One is the name is Kobairo Lab. That is an gradient heating furnace facility, and the other one is multi-purpose general workstation called multi-purpose small payload lab. And in the near future, we will launch some exposed payloads, the port share type payload, and also we plan to launch the pressurized experiment facility called Aquaricat. In 2012, we plan to launch a new electro-radiation furnace facility, and in 2013 or 14, we plan to launch another heavy payload on the exposed part, which is a calorimetric electron telescope. That is our future plan for continuous developing our Kibo module. So those are okay. The next chart shows you the occupation of each discipline or each area of research in the past 1 year. You can see that from this view graph that almost 50%, half of the Kibo resources consumed by science research. In the meantime, we spend about 10% for industrial application area research and 20% for education or promotion activities, and 10% for human research, and another 10% for the maintenance of the facilities. It's about 2 years have passed since we developed the Kibo module, so we have some anomalies or malfunctions. So we spend about 10% resource for continuous maintenance to keep the smooth operation. That is the current status of the resource balance in our Kibo module. I will show you some results in the past half year. The first discipline is life science areas. The life science is one of the major research areas in our microgravity research, especially how we would like to find out how the creatures growing up on the 1G Earth surface will respond to the space conditions such as microgravity or high energy radiation. So this picture shows you our life science facility in the Kibo module, which is cell biology experiment facility and clean bench. Clean bench is a kind of grow box to operate the life science bio objects inside the space station. We conduct some experiment using the C. elegans. C. elegans is one of the major model specimen for the life science. And also we conduct the plant experiment. Plants are very unique response to the microgravity. And also we conduct the cell culture experiment using some human cells or marine cells to study about radiation effect or microgravity effect to the living cells. Those are life science area researches we are conducting in the space station in recent days. Another discipline is an industrial application. One is protein crystallization, and the other one are nanotechnology related experiment. The protein crystallization is one of big area for industrial application, especially for the new drug design or new protein design for our benefit for the daily life. The proteins are carried to the space station and make a good quality crystal and return back to us for the X-ray analysis. So just look at the picture of these proteins. There is an on-ground-based crystal and also in space crystal. Some example of the pictures, and we can see some the crystals grown up in space has a good quality compared to the ones on the ground. So it will improve the resolution by X-ray analysis. One crystal for the example of this one, look at some examples. One is on-ground based, it's about 4 angstrom to become 2 angstrom to improve the resolution. That is a very good result from space. And also the protein crystallization is one of our collaboration area with our Asian colleagues. Malaysian researchers also participate in this program. Other area is a nanotechnology experiment. Nanotechnology means small, very small materials. So we use microgravity as a good condition to crystallize or formation of the small construction. One is nanotemplate. You can see brown one. This is 5 nanometer pattern of the crystal. We are developing this kind of small pattern under the microgravity to use as a template. For example, the application of the integrated circuit. Another application is nanoskeleton. You can see a small tube construction over there. This is another crystals grown, they are trying to grow up in microgravity. This area is expected to apply for photocharacteristic materials. Those are the examples of the industrial application area. Another area is human research. The astronaut health is most important thing for the manned space activity. So we research several different areas about human research to keep the astronaut health condition. So we are monitoring astronauts' body condition using a small electric. This is an example of electric cardiogram. Astronauts wear a small device to monitoring his heart rate for 20 hours per day. That kind of monitoring we are conducting for several different astronauts. Another area is how to protect the bone degradation or muscle degradation from muscle degradation of the astronauts while he or she is spending a long day in the space station. The Koichi Wakata trying to take medicine, which is a kind of bisphosphonate medicine, to protect his bone degradation from the microgravity. Another area is how to protect high energy, how to protect astronauts from high energy radiation heat. The picture shows the phantom of the human body called Matryoshka. This program is collaboration between Russian, European, and Japanese experiment to monitor the radiation effect deep inside the human body. Another discipline is microgravity science area. We are conducting some fluid physics experiment in the microgravity condition. This particular experiment called Malangoni experiment is studying about Malangoni effect, which is a surface tension derived protein in the liquid. So under the microgravity, we can easily make a huge liquid bridge with a free surface. So we are studying about the Malangoni convection using this kind of microgravity effect. Another interesting area is in astronomy. The Kibo module have an exposed facility. So from the exposed facility, we can perform several space monitoring experiment using several different devices. This picture shows you the one example, the payload called MAXI. It's a monitor of all sky X-ray image. Since the space station is just going around the Earth, 90 minutes, just one cycle per 90 minutes. So the astronomical payload can observe all sky every 90 minutes. So using this feature, we will monitor the X-ray of the all skies per 90 minutes. So every day we can observe all sky many times. Once this payload find out, for example, a new X-ray source such as new stars, then that information broadcasted to the ground station, and ground astronomy start to observe much detail about that stars. So one example is here in the MAXI find out new stars in the Sagittarius area, and that picture shows you that example, which was formed around early in 2010. This is a kind of astronomical area. Another example is also the exposed facility payload, which is monitoring the around the space station altitude. So I'll show you the data of the electron density around the space station altitude, that is 400 kilometers high from the ground. So maybe you can see the South Atlantic anomaly. It's a high energy particle, very low orbit. The yellow part on the South America show you that the anomaly, called South Atlantic anomaly. This data is open to the public through the web pages, so you can see the everyday data at this website. Okay, this is another example of the exposed payload, which is a sub-millimeter cylinder, which is an Earth observation area. We plan to study about the ozone layers by this payload. Unfortunately, this payload is now in the trouble, so this is the very early data, and currently this payload is stop operation. So we have some anomalies also on the space station. This is one example. Another interesting area is education and promotion. Astronauts tried to some artistic experiment or demonstration proposed by an artist, or sometimes proposed by students or small children to show them how the microgravity will affect to our nominal phenomenon. The light upper side show you the activities of moon score. Moon score is just taking a photo of the moon from the space station and make a kind of music score to look at the moon itself as a score of the music part. That is one of the art of the microgravity or space station application. The lower right side, you can see the space dance. Koichi Wakata trying to microgravity dancing in the Kibo module, and also this rainbow color structure is art of light called spiral top. Also, Koichi Wakata tried this kind of the art of the light in the microgravity. The left side, I pick up the space gardening. Space gardening means some plant grow, some trial to growing up plants in the gel module. So Soichi Nobuyoshi and other astronauts try to growing up the small plants in the space station. The next chart shows you some new payloads which will be launched to the space station only in the next year. One is Payloads. I already mentioned in the previous slide. It's a gradient heating furnace. This payload will be used for some material production in the microgravity. Another payload is a multi-purpose workstation called small payload, multi-purpose small payload rack. This is one of our proposed facility for our collaboration, because this facility can support a very small payload. For example, to provide an electricity or communication or closed environment. So you can bring the small payload to this multi-purpose lab and conduct the microgravity experiment much easier much easier to using heavy facility. And okay, another example is a small satellite deployment from the Kibo. We can use the Kibo exposed facilities such as robotics arm to deploy the small satellite from the Kibo pressurized module. This is a kind of future plan. Okay, so this is an example of using multi-purpose lab. Currently, we are developing the some small payloads for the multi-purpose lab. So this is an example. One is a combustion chamber. So combustion is very interesting phenomenon to analyze under the microgravity condition. So we prepare a very heavy container to enclosing combustion experiment. Because combustion phenomenon itself is not safe to conduct in the open air in the module. So we prepare this kind of heavy container to conduct combustion experiment much easier proposed by the scientists. Another example is an aquatic habitat over here. We will plan to prepare some aquarium on the space station. The medaka or zebrafish, a small freshwater fish, is one of the good model specimen to study the microgravity or radiation effect for the whole body. So we will launch this aquarium to the space station in schedule 2012 and start experiment in 1.5 years beyond. So this is one of another example of the small payload. Another example is an electric levitation furnace. This electric levitation furnace are using the microgravity condition to levitate small metal or ceramic materials by electric force and melt and recrystallize without any container. So containerless experiment we can perform using this electric levitation furnace. This is also our future payload. Okay, next slide show you some activities that about the collaboration with our colleagues in Asian Pacific countries. Our Japanese government encouraged us to collaborate much more activity with Asian countries. So the space activity, the report issued by Space Activity Commissions this year, that the gateway to ISS in Asia. So we are encouraged to promote more activity with our colleagues in this Space Environment Utilization Working Group participants. And to promote this, JAXA has established a new office called Kibo Utilization Office for Asia. This chance in this summer, but in Australia it's in the winter. So this is an last August time frame we established this new office or new group. And also we establish or re-establish task force team to promote our activities. So this will be explained by Dr. Takauchi later. This table will show you several our activities performed or planned. Let's see. So parabolic flight experiment. Parabolic flight by airplane is a good opportunity for study the microgravity effects on the ground. So we encourage the students to participate to the parabolic flight opportunity. Okay, our Asian colleagues also attend this parabolic flight experiment. In this year, we also expected 2 teams from the Space Environment Utilization Working Group from Malaysia and Thailand. Students will participate to the parabolic flight experiment. And another one is a protein crystallization. I already mentioned about that. And next one is Space Seed for Agile Future. This project is to plan to launch several plant seeds to the space station. This is also presented more detail in later. And next one is educational demonstration by Japanese astronaut. In next year, next Japanese astronaut candidate will be Dr. Satoshi Furukawa. He will plan to perform also educational activity, and we also announce this opportunity not only in Japan but also in this Asian Pacific countries to participate this demonstration experiment. And next one is small payload in Kibo. This is not yet performed, but we encourage to bring small payload to Kibo to do some experiment using the microgravity or space radiation condition. And in the future, we expected to do the full-size experiment in Kibo with collaboration of this working group member country. So this is our future expectation. So the conclusion: the ISS Kibo utilization is successfully continuing. Of course, we have some troubles or anomalies in daily life of the space station utilization and operation. However, the space station itself operating smoothly in the past 1 year, and we expected to continue this smooth operation of Kibo and ISS itself. And we also prepare for our collaboration in the near future. Especially, unfortunately, the space shuttle itself will be retired in the next year. We expect only 2 or 3 flights remaining. So after that, we will using maybe a United States new vehicle or Russian colleagues Soyuz Progress vehicle, and also European and Japanese vehicle. So we will prepare for the next era of the space station and the space station utilization. And our group, this working group activities, several efforts are continuing among our partners, and we are growing our bilateral or multilateral collaboration in the future of our program. That is all my presentation. Thank you very much.
Thank you. Any questions? maximize the efficiency of the JN Kibo utilization, I believe the preliminary data from a ground-based test will be critical to justify their own experiment. But for preliminary data questions from ground-based, I believe the parabolic flight is the realistic way to go. But as far as I know, there is no countries that operate the parabolic flight except for Japan, JAXA. So from this perspective view, JAXA has any intentions to expand that opportunity, such opportunity, I mean the parabolic flight to space, other space agency, not only to student group, or if not possible, how about to student group directed by the other space agency?
Okay, so your question is there any plan in JAXA to provide the parabolic flight opportunity, not only students, but also researchers, or to prepare for the space experiment? Is that your question? Okay, so at this moment we are running. Yes, you're correct. We are running the parabolic flight opportunity not only for students, but also we use the parabolic flight for the preparation of our space experiment. So Japanese researchers sometimes using the parabolic flight opportunity to prepare the space experiment, or to check the function of the facilities or experiment equipment before launching to their real space flight. The opportunity to provide that useful parabolic flight to Asian colleagues is one of good discussion point, I think. So may I ask Kamingai-san to add to some comments?
Yes, yeah, I think that currently the parabolic flight is created by APRSAF17 and organized by Japan Space Forum. So I think that space story can. But anyway, as Mr. Fujimoto said, we have in JAXA in Japan, I mean, we have funding for Japanese researchers to do the parabolic flight experiment prior to the real Kibo experiment. And addition to that, we are open to parabolic flight to program charge. I think okay, there are two possibilities. I think we will have a joint collaboration framework, or Diamond Air Service of the Japan Space Forum can provide with in a commercial way for the utilization opportunity.
The reason I'm asking this question is, as you know, the current experiment for the joint experiment with JEM, the Kibo module. So from this perspective view, I believe to maximize, as I said, to maximize efficiency. So I believe the preliminary data is valuable to evaluate the mission unit device or payload development. So.
Yeah, I understand. Okay, so yes, there are two ways to, necessity for parabolic flight. One is hardware development, one evaluation, or the other one is experiment with research application. So Yes, with Harry, as you mentioned, we are now in the process of study for incorporation. New hardware development and experiments, utilization course. So I think I myself think that such kind of activity necessary for the hardware development will be included in some way in the future cooperation framework.
As far as the experiment on the airplane, in the framework of the grant research funding supported by the JAXA, and we have a lot of experience for about 10 years about the development in the hardware, not only for the development of hardware, but also the scientific and engineering results. If you have any question about what intention to do some activities to please come to us because the airplane we are operated by the Diamond Aircraft Travel Company. They provide flight opportunity on commercial basis. Japan Space Forum will coordinate users between users and Diamond Aircraft. So if you have any concern or some interest, please come to us. Any information.
Are there any
do you plan to round it out from the Kibo?
This is kind of in this presentation just an example, but the small payloads such as cube size, for example, 10 centimeter, 10 centimeter, 10 centimeter. That is an example of a small payload I brought up here because our NASA colleagues prepare so-called nano payload. That is a cube, not nanometer, but cube size payload. They support that kind of small payload experiment in the NASA module. So that is an example. So JAXA also plan to support a small size payload operating inside the pressurized module, not really a CubeSat. So that is what I would like to mention in this chapter.
Okay, I will the CubeSat is not a satellite plane because the closed container which can contain some experiment apparatus or material in the pressurized module. By having the sealed container, you don't have to be worried about safety evaluation procedures. So you can put experiment very easily into the pressurized module. That kind of system we would like to have for the easy access to the basic experiment. And it may be confusing. He has another presentation at the bottom of this chart. This is a different things from the CubeSat. We are now planning to develop new systems to deploy. This is small satellite. Currently, the size is about 50 or 40 centimeter cubic, and 50 kilograms. So by using this system, we can launch the small satellite in a pressurized module. And the advantage of this system is the crew can check the function just before the deployment in a pressurized module. And then we will put the small satellite into the air to transfer it to the outside module. Then robotica grab it and slow deploy to the home. And when I explain the details, but the satellite cannot stay on orbit for a long time because the orbit is the same as ISS or the other people. So maybe it can stay about a month, more month.
About the tracking system for a nanosatellite, it can be done in the ground or it can be done on the JAXA module?
We don't have any plan to communication with the satellite. So you have to prepare the communication with the satellite as well. Are there any comments or questions?
Concerning the small micro from the tubes, the JAXA provides some flight opportunity on occasion of the H2A launch vehicle. So far, the JAXA launched about 10 small satellites. The biggest one is 50 centimeter cube, and the small one is 10 centimeter cube. So those flight opportunities will be provided by the JAXA continuously on the occasion of the H2A launch vehicle. If you have any interesting.
Actually, we're preparing for the biological experiment using the. At this stage, we're not sure, but we plan to develop any nanosatellite like a CubeSat for biological tests. So we may have interest.
So in that case, you just receive some experiment data on the telemetry.
Yeah.
So you don't want to retrieve any the samples.
Actually, we want to retrieve the data on the ground using our facilities. So the CubeSat will be designed to send the signal to ground.
Okay, so in that case, I mentioned earlier some small satellite flight opportunity can be provided by JAXA. The JSF will be the coordinator between JAXA and other university or some institute.
Okay, are there any yes.
Question. Within your utilization program, have you decided basically the percentage of resources that go to different programs like life science or physical science, education, outreach?
Yes, in the overseas, we spend about 70% to science in 2008 time frame. However, this chart shows you the current result of the consumption of our resources. This is crew time based. However, I think it indicates our resource balance between the different disciplines. So at this moment, we spend about 50% to the pure science area, and spend 11, so about 10% to the industrial application. This is also an research area. In the meantime, we spend 10 to 20% to each for human life science and education. In this, the beginning of this year, we spent 20% for education. However, this is because our Japanese astronauts on board the space station. So, I think it depends on the situation. But anyway, we will spend 10 to 20% each for human life science or education, and 10% for maintenance, continuous maintenance. That is our current status, and almost indicate the resource balance, Japanese resource balances to each different discipline.
Okay, thank you. And are there any other questions? Okay, thank you very much.
Thank you.
And according to my chart, the next one is from London, but this time is just time for the synchronized copy break time. So I think I would like to propose to have a copy break.
Can you check if you have an registration, please check. If you don't have a registration, just put your name in brown. Okay.